Okay, guys, what we're going to be talking about today um, is circumference and area of circles, um, 8.7, Chapter 8, Section 7. Um, so let's get right to discussing how to find the circumference and the area of each circle. Let's start with finding the area of the circle. Again, remember area, we're talking about finding the space inside of this two-dimensional space figure. And so if we take a look at number one, it says find the circumference and the area of each circle. So number one, um, let me reorientate the board real quick, please, so it looks nice for us. Okay, so on number one, the area formula, um, to find the space inside of a circle is going to be pi times the radius squared. Um, so a couple things. The radius is a segment um, that whose one endpoint is the center of the circle and the other endpoint terminates on the arc of the circle. So that blue segment I just drew is a radius. Now, the other thing we want to know for today's lesson is if I draw this red segment, that's another radius. So now we have two radii, and two radii are equivalent to one diameter. So two radii is equivalent to one diameter. So we want to make sure we understand that today. And a diameter is a segment whose endpoints are on the arc of the circle and that goes through the center of the circle. So to find the space inside of this circle, um, we're going to find the radius value, which is 7, raise it to the second power, times pi. So the area is going to be 49 pi square centimeters. So the area of this circle or space inside of this circle is 49 pi square centimeters. Um, the approximate value of pi is approximately 3.14. Some teachers prefer their students to leave the area of this circle as 49 pi square centimeters. Some teachers want their students to then take 49 and multiply by the approximate value of 3.14 and then give it as a decimal answer in square centimeters. I usually like my students to leave all of their areas in terms of pi. Now, the circumference of this circle in number one. Okay, what I want you to imagine when we're talking about circumference of a circle, I want you to imagine in number one that this circle is a belt, let's say, or a rope that we've made into a circle. And we want to find the length of this rope or belt. So you want to imagine, let's just use the example of a rope. Imagine having to take some scissors out, cut the rope, and lay it out as a segment as such. And use a ruler or a tape measure to find the length of that segment. So when we talk about finding the circumference of a circle, we're actually talking about the length of the circle or length around the circle. So circumference is a length, okay? So when we're finding the circumference of a circle or the length of a circle, we can go 2 times the radius times pi, or we can go with pi times d. These are equivalent equations because d stands for diameter and radius stands r stands for radius. And because two radii are equivalent to one diameter, either equation suffices. So number one, the length around this circle, okay, using 2 pi r or pi times d. 2 times the radius is 7 times pi. So the circumference is 14 pi centimeters. So the length around this circle is 14 pi centimeters. Okay, in example 2, let's find the area first. So the space inside of the circle is area equals pi times radius squared. I want you to realize in number 2 that they have given you the diameter length, which is 10 meters. So we need to cut that in half to find the radius. So the radius has to be 5 meters. So the diameter is 10 meters. Therefore, the radius is half of that. So the radius is 5 meters. So the space inside this circle is going to be 5 squared pi. So the space inside of this circle is going to be 25 pi square meters. I always like to talk to my students about good numeracy skills, having good numeracy skills. And what I want you to start to think about is if the area of this circle is 25 pi square 25 pi square meters, and we realize that the value of pi is approximately 3.14. I always talk to my students about, well, 25 pi has got to be around what value? Well, if that's basically 25 times 3, right? So 25 pi has got to be close to whatever 25 times 3 is. So if we triple 25, we'll get 75 square meters. A little bit more than that because pi is a little bit larger than 3, but approximately, thinking it logically. Okay, the length of the circle, okay, and number 2. Now I'm going to go, instead of with 2 times pi times the radius, because 2 radii is 1 diameter, I'm going to use the equivalent equation of circumference equals pi times diameter. And the diameter is 10 meters in length. Therefore, the length around this circle is 10 pi meters. Oops, sorry, I think we had some other problems to do. Okay, yes. All right, now in number 3 and number 4, we'll just do one of these. Now we're using the formula for the area of a circle, but now we're not looking for the area of the circle, we're looking for the value of the radius. Okay, so we want to make sure that we understand what we're doing here. So the directions say the area of each circle is given. Solve for the radius of the circle. So again, the area equation of a circle is area equals pi times radius squared. We're given the area, so properly substituting our knowns. So now we're going to substitute 13 in for the area equals pi times radius squared. Again, they want us to find the length of the radius. So next thing we're going to do is divide both sides by pi. Okay, so 13 divided by pi, which is basically 13 divided by 3.14 approximately, or you can use a calculator and type in 13 divided by pi, or you can type in 13 divided by 3.14. I'll go ahead and do 13 divided by 3.14, and we'll get approximately 4.14. So we get 4.14 equals the radius squared. Once again, 13 divided by pi, which is approximately 3.14, gives us 4.14 equals the radius squared. Now the inverse of squaring is to take the square root of both sides. And so our radius is going to be approximately plus or minus the square root of 4.14. So again, we got to now take the square root of 4.14. So take out our calculators. Go. And approximately is 2.03, plus or minus 2.03. Remember, when we're using the square root property, it's plus or minus 2.03. Now, length can be negative, so we're going to ignore the negative value for the radius, and the radius value is approximately positive 2.03 units in length. Okay, so again, this is a problem where we're using the formula for the area of a circle. However, we know what the area is, and we're looking for the length of the radius. All right. Now, knowing what we know about the area of a circle, now what we're being asked to do is find the area of each circle, then the area of each sector, and then the circumference of the circle. The key, what I want you to realize here, is that when we're looking for the area of the sector in number 1, that's just the shaded part. Now that I'm now shading in red. Okay? What I want you to understand is what's really happening is that first and foremost, we just learned how to find the area of the whole circle using area equals pi r squared. Okay? So the area of this sector, which is in red now, is definitely a fractional amount of the total area in blue. So once we find the area of the circle, which we just learned how to do, we can then multiply that by some fractional amount to find the area of the red piece, known as the area of the sector. So let's start off by doing what we had just discussed. The space inside of the circle, the blue, is equal to pi times radius squared, the length of the radius being 6 feet. So we're going to go 6 squared times pi. So the area of the whole circle is going to be 36 pi square feet. Okay, 36 pi square feet is the area of the whole circle, which was in blue just a few seconds ago. But we don't want the area of the whole circle. We want the area of only the sector. So we need a fractional amount of that. Okay. How are we going to find that fraction? Well, first question is this. If I start along the arc, go all the way around the arc, come back to the point where I started, how many degrees did we rotate? I'm hoping you would say that we rotated 360 degrees. So our fractional amount that we're looking for is how much we rotated from here to here in comparison to 360 degrees, which is only a 30-degree amount. So the fractional amount we're looking for is 30 degrees divided by 360 degrees. So let's simplify this ratio now. So the zeros cancel, and now we're left with 3 divided by 36, and both of those are divisible by 3, which is going to give us 1/12. So the area of the sector, just the little shaded part that we had in red a few minutes ago, is going to be found by taking 1/12 of the total area. So here we go. So the area of the sector is going to be the area of the whole circle times a 12th. We want a 12th of 36. So now if we write 36 pi as a ratio, we're going to take numerator times numerator. So 36 pi times 1 is 36 pi. And denominator times denominator, 1 times 12 is 12. And then if we reduce this ratio, if possible, by a common factor, okay, I'm pretty sure 12 goes into 36 and 12 divides into itself. So 36 divided by 12 is going to be 3 pi. So we got 3 pi, and 12 divided by 12 is 1. So the area of the sector is going to be 3 pi square feet. So 3 pi square feet is the area of just a little piece of pie. Okay, just a little shaded part. Okay. I think down at the bottom we have blanks to fill everything out. We just found the area of the sector, which is 3 pi square feet. We had first found the area of the circle, 36 pi square feet. Last but not least, which we did earlier on the previous page, how to find the circumference of the circle, or aka how long the circle is. We're going to go with circumference equals 2 times pi r, or circumference equals pi times diameter. If we look back at the diagram, the length of the radius is 6 feet. So the circumference is going to be 2 times 6 pi, or the length around the circle is going to be 12 pi feet. So the length around the circle is going to be 12 pi feet. Okay, let's do one more of these because they're kind of challenging. Okay, so let's look at number 2. Okay, let's start out by finding the area of the circle. So the area of the circle, space inside of the circle, everything, is going to be pi times radius squared. The radius is 10 inches, so we're going to go 10 squared times pi. 10 squared is 100. So the space inside of the circle is 100 pi square inches is the area of the circle. So the area of the circle is 100 pi square inches. Now, to find the area of the sector, the little fractional amount, that was the area of everything there. We just want the area for this piece of pie in red, just the red now. So what we're going to do, remembering that one rotation of a circle is 360 degrees, and our fractional amount is only 120 degrees of 360 degrees. So our fractional amount is going to be 120 degrees of 360 degrees. The zeros cancel, which leave us with 12 divided by 36, and both of these are divisible by 12. So 12 divided by 12 is 1, and 36 divided by 12 is 3. So the fractional amount we want to take of 100 pi is a third of that. Okay? So the area of our sector, is going to be found by taking a third of 100 pi. Okay. So the area of the sector is going to be 1/3 times 100 pi over 1. Numerator times numerator. So 1 times 100 pi is 100 pi. Denominator times denominator is 3 times 1 is 3. Okay? Now, can we reduce this ratio? No. Okay? So I like to have my students leave it as an improper fraction. And the area of the sector is 100 pi over 3 square inches. So the area of just the red part is going to be 100 pi over 3 square inches. Last but not least, how long the arc is, how long the circle is, circumference. Okay, it's going to be circumference equals pi d, or circumference equals 2 times pi r. And since they gave me the radius length, we're going to go with 2 times the radius, which is 10 pi. So how long is this circle? In length, 20 pi inches. So 20 pi inches around. Okay, that's all we have for you guys today. Thank you for tuning in.